Problem 17. Anna used 32 small white squares to frame a 7 by 7 picture. How many of these small white squares does she need to frame a 10 by 10 picture? This is our option. We know that the frame for a picture is 7 by 7. 1, 2, 3, 4, 5, 6, 7. And then we add 2 more tiles to make it 9 by 9. What we would do for 10 by 10 picture, first we need to know how they find 32 small white squares. Unless we count, we would not be able to know. So let's do how they find it out through solving, through the math skills. So we know that this is 9. So 9 by 9 covers 81. 7 by 7 tile square covers 49. So if we subtract 81 minus 49, we get 32. Let's solve this. So for a 7 by 7 picture, we have outer frame is 9 by 9 square with 7 by 7 cutout. So 9 by 9 means 81. 7 by 7 means 49. So 81 minus 49 gives us 32. And this is how we are able to find out 32 small whites. Now we know how to determine 32 small whites. Can we determine for 10 by 10 picture? Yes. For a 10 by 10 picture, the outer frame would be 2 more. 12 by 12 square with 10 by 10 middle cutout. That is a picture, size of the picture. That means 12 into 12 gives us 144. 10 into 10 gives us 100. We subtract and we get 44. So we will have 44 white stripes for a 10 by 10 picture, which is answer option C. Great job. Let's move on to another problem. Problem 18. The pages of books are numbered 1, 2, 3, 4, 5 and so on. The digit 5 appears exactly 16 times. What is the maximum number of pages this book could have? These are our options. We need to count how many times the digit 5 appears in the page number from 1 to we don't know. And the reason is that we have a fixed amount is 16 times. So once we know those numbers, we can fix it to 16 times and then we can get our answer. So let's do step by step. First, count how many times 5 appears in each places. So whenever we talk about digits, always remember that we divide it in terms of unit place and 10 place. So we count the 5 digit on the unit place first and then we will count 5 digits on the tens place. So let's move on. So count 5 in the units place. I have taken a limit from 1 to 75. We can take 1 to 50 as well because we know the limit. We know it appears 16 times. So we count at the unit place 5 as 5, 15, 25, 45, 55, 65, 75. And we say it appears 8 times. Now we will count 5 in the tens place. And again from 1 to 75, we count 50, 51, 52, 53, 54, 55, 56, 57, 58, 59 to 10 times. Now we know it is 16 times. So what we can do, we can take 10 times from here and can take 6 times from here. That means page number 55. So 16 occurrence would be 6 plus 10 is equal to 16. And 6 is, we cut this out, make it 6. Now we see that we have 59, 55. So it's not going till 65. It's less than 65, that is 64. So what is our answer? Since we have exactly 16 occurrences, the maximum number of pages in the book is 64, which is answer option B, 64. Perfect. Let's move on to the next exciting challenge. Problem 19. A hallway has dimensions shown in the picture. A cat walks on the dashed line along the middle of the hallway. How many meters does the cat walk? We need to determine how much cat walks from this here, here, and here, and what is its distance. We will solve this problem very carefully, step by step. So let's start. First, we know that a cat walks from here to here. So we know this distance. This is 36 and total is 14 meters. Now we have to determine how much is this distance. So we know 40 minus 36 gives us this distance completely, which is 4 meters. We know the cat has walked on the middle of the hallway. So half of 4 is 2. So cat walks 2 more. So we have 36 plus 2 gives us 38. That's the first distance she walks in. Now the cat walks on this dash line. We know this is till this here, it is 20 meters. So from here to here, how we determine is we know this is 4 meters. How do we know this is 4 meters? Because this is 8 meters. Half of 8 meters is 4 meters. So from here to here, it is 4 meters. So 20 minus 4 gives us 16. So this much is 16. Now we know that the cat has walked this much is 16. Now we have to determine this distance. Let's clear the screen. So we determine till here. We have to determine from here to the here. We know cat walks 6 meters. That is half of 6 is 3. So distance from here to here is 3 meters. So we add 16 plus 3 gives us 19 meters. So now we know cat walks till here 19 more meters. Now to determine the distance from here to here, we know, take this out, we know the distance from here to here is 2 meters. And total is 28. So 28 minus 2 gives us 26, and 26 meters cat walks in. So from here to here it's 26 because the full is 28 minus this distance gives us this distance, and it becomes 26 meters. Now we know cat walks 38 meters here, 19 meters here, and 26 meters here. The total is 83 meters. And 83 means this is our option E, 83. Problem 20. In a park there are 15 animals, cows, cats, and kangaroos. We know that exactly 10 of the animals are not cows and exactly 8 are not cats. How many kangaroos are in the park? These are our options. We know that the total number of animals are 15. That is cow, cats, and kangaroos. Let's find it out. Animals that are not cows. We are told that exactly 10 of the animals are not cows. Since the total number of animals is 15, the number of cows can be 5. So 15 minus 10 gives us 5 cows. Similarly, we can determine animals that are not cats. We are given exactly 8 are not cats. So we minus 15 minus 8 gives us 7 cats. Now we know number of cows, number of cats. Then we can determine number of kangaroos by subtracting 15 minus 5, that is cows, 7 cats, gives us 3 kangaroos. So our answer is option B, 3 kangaroos. Problem 21. One of 5 children, Alec, Bartek, Cesare, Derek, and Adek, has eaten a cookie. Alex says, I haven't eaten a cookie. Bartek says, I have eaten a cookie. Cesare says, Edek has not eaten a cookie. Derek says, I haven't eaten a cookie. Eric says, Alex has eaten a cookie. Only one child lies. Who has eaten the cookie? These are our options. We know that only one child is lying and the rest are telling the truth. Let's analyze their statements carefully. If Bartek were telling truth, I have eaten a cookie, then the other statement should be true except for one, and that is Edek. Edek says Alex has eaten a cookie, which contradicts this. This would mean Edek is lying. Now let's verify that. If Edek is the liar, then Alex, I haven't eaten a cookie, it's true. Bartek, I have eaten a cookie, that's true. Cesare says Edek has eaten a cookie, that is also true. Derek says I haven't eaten a cookie, that is true too. And Edek says Alex has eaten a cookie, that is false. So here, who is lying? It's Edek is lying, and only one statement is true, is Bartek, I have eaten a cookie. And this is our answer, option B, Bartek, I have eaten a cookie. The cardboard is folded into a 2 by 1 by 1 box. Which picture shows this box? Let us do a careful observation of this. So we consider as an option A. Let's pick that option. If we see that there are two cyan colors together, so if this is two colors together, that means this one would be in there and this red would go on a base. So if this is a red in here, that is not right. Let's do again, option B. We have two blue on top. On the side we have cyan color and red, and this would be on the side wrap and this will go on the base. So this seems like option B could be our answer. Let's move and check option C. So we have red and cyan color. So we have red and cyan. If this is the one, then side should be white. That should not be an option. D. If we have red and cyan on top, and on the side it should be two color of these. So this is not our option. Option E, we could not have white all together. It should be on the side or in the front. So answer is option B is our answer. Perfect. Problem 23. Anne and Eve string beads onto an empty thread. Anne starts with on the one side of the thread putting these beads. Eve starts from the other side of the same thread string with these beads. Consequently, only one picture shows a piece of thread with beads strung by both girls. Which one? These are our options. So these are the questions where we carefully observe a pattern. So what I usually do is I fix myself on a pattern and see which pattern follows and then eliminate which does not. And then we'll move from there. So looking on this, we know that a blue and a red pearl are strung together. So let's see which one has blue and the red pearl together. We have option A, yes. We do not have that pattern in here, so we remove option B. We do not have a blue and then red bead, we remove this, and this is also reverse, we remove this, and now we have option A and E. Now let's move on to the next pattern. So we have the difference between this is we need to have a yellow, so we have both have a yellow. Then we have a star on both, that is correct. Now the difference is between the red pearl and the blue pearl. So we see that here blue one goes with red, blue goes with red, and after star we get either a blue one, and then we get a triangle. So we follow this pattern. We see here with the star we have blue, and then here we would get a triangle, and then we get a yellow bead, and this is how the circle begins. So our answer is option E. This is the pearl set which we would get. One can exchange a red token into 9 white tokens, while the other can exchange a white token into 5 red tokens. Anja has 1 white token. What is the fewest number of exchanges after which Anja can have twice as many red tokens as white tokens? These are our options. Let's solve this problem step by step. Anja starts with 1 white token, and the machines available has machine 1 exchanges 1 red token into 9 white balls. Machine 2 exchanges 1 white ball into 5 red tokens. Goal is to figure out how the fewest number of exchanges needed for Anja to have twice as many red tokens as white tokens. Strategy: let's track the number of red and white tokens after each exchanges and see how we can reach the desired condition. So let's have transactions white and red. Now we start with machine 2 because we have 1 white token. So we start with 1 white to 5 right. So our white is 0, red is 5. Now let's have some white balls in there. So we have transaction 2 done where we do 1 red and converts to 9 white tokens. So we have 9 white tokens and 4 red because we used it. Now try to match it or to the way that it is twice. Transaction 3, let's add more red. So we have taken on 1 white out of it and increase the red. So it makes 4 plus 5 gives us 9. So let's do transaction 4. We do 1 white converts to 5 red, and we have 1 less white, and then we get 14 red. So this is what it is, that it's twice as many red tokens as white tokens. And our answer is option C, 4. It takes 4 exchanges to achieve the condition where there are twice as many red tokens as white tokens. So this wraps up part C from the 2019 Math Kangaroo for grade 3 and 4. Make sure to like, subscribe and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Thank you.